All right, so today we're going to talk about some matrix operations. We're talking about matrix addition, subtraction, scalar product. We'll talk about matrix equations, and I'll try to keep the video short and sweet and to the point because I think a lot of the ideas are pretty straightforward. So let's start with matrix addition, right? So when we do matrix addition, right, all we're going to do is we're going to take each input in a matrix, right, corresponding inputs, and we're going to add them together. Right? So if we have matrix A plus matrix B, we're going to take corresponding inputs, 2 plus 1, to give us 3, right? All we did is just did 2 plus 1 and input it into that, that place, right? Negative 3 plus 0 gives you negative 3. 0 plus negative 3 gives you negative 3 here. 5 and 1 gives you 6. 7 and 2 gives you 9, minus 1 over 2 plus 2 gives you 3 over 2, right? So you're just adding corresponding inputs and you're putting them in that spot. Okay, subtraction, same thing, except you are subtracting from each other, right? So corresponding inputs, 7 minus 6, it's going to give you 1, minus 3 minus 0 gives you minus 3. Right? And you can kind of just fill in the rest. So 1 minus 3, 6, minus 8, 0, and minus 4, right? And you just get that from subtracting. Lastly, scalar product. Okay, you could probably guess what's going on, but you're going to take each of these inputs and you're going to multiply them by 5. Essentially distribute that 5 to every single input that you have here. Right? When you do that, you'll get 10 minus 15, 0, 25, 35, and minus 5 over 2. Okay? And so that's all you're going to do for the scalar product. Now, note, for the above operations, the matrices must have the same dimensions, right? So here, right, they are the same dimensions, n by n. Okay? If you wanted to add, so an example that you couldn't do, right? Say you had matrix C, so 7 minus 3, 0, 0, 1, 5, and say you wanted to add that to matrix A, which is 2 minus 3, 0, 5, 7, minus 1 half. Okay, you could not do this, okay, because this has 3 columns and 2 rows, and this has 3 rows and 2 columns. So you cannot do addition, subtraction, okay, if the matrices are not the same dimensions. And we saw in examples, right, they all had the same dimensions. Okay, moving right along. Last thing we're going to talk about is matrix equations, right? So if you have matrix A is equal to this, matrix B is equal to this, and you want to solve for an unknown matrix X in this example, 2x minus A equals B, okay? What you're going to do is you're going to solve for X in the example first, okay? And so you're going to add A to both sides and divide by 2. So X is equal to 1 half B plus A, right? Just like if you were solving for a variable. The only difference here is you want to solve for the matrix, right? You want the actual matrix with the actual inputs. And so you're going to use those matrix operations from before to solve this, right? And what I like to do is maybe plug it in first. Since we have them listed here and because of space, I won't do that, right? But X is going to be equal to 1 half. Okay, now we need to add matrix B and matrix A, and we need to double check that the matrices are the same dimensions. We see that they are both a 2 by 2 matrix. Okay, 2 rows, 2 columns, 2 rows, 2 columns, so that's okay. So we can go ahead and we can add those together, okay? When we add 2 and 4, 6, 3 and negative 1, 2, negative 5 and 1, minus 4, 1 and 3, 4, okay? So now we need to we did the addition, we just need to find the scalar product here. And so essentially we're just going to multiply and distribute the 1 half in, right? And so matrix X is going to be equal to 3, 1, negative 2, and 2. okay? And that would be your final answer, right? So all you're doing is solving for x like you normally would, and then applying the operations that we talked about before. And that should be everything that you need for this unit, okay? After we assign our upcoming project, we'll talk about matrix multiplication, but will have a little bit of time for that. So hopefully this video was to the point, hopefully it made sense, and I will see you guys later.